Hello everyone, so today we are going to solve this question which is Trionic Array 1. Okay, so what this question says that we have been given nums of length n and a trionic array is such that from we take three indices. Okay, first is 0th, second is last index, and these two index are such that from 0 to p we have a strictly increasing array. From P to Q, we have a strictly decreasing array, and then again from P to n minus 1, we have a strictly increasing array. Okay, this is what a trionic array is. Okay, now what we have to do, suppose this is our array. Okay, that is 1, 3, 5, 4, 2, 6. So first let's take 1. Yeah, 3 is greater than 1, correct. 5 is greater than 3, correct. Okay, but 4 is not greater than 5, so we will have our p here. 0 is here and minus 1 is here, that's obvious. Okay, now 4 is strictly decreasing than 5. Okay, 2 is strictly decreasing by 4. Okay, so we have q here because 6 is not strictly then 6 is strictly increasing from 2. This will be increasing, so here what we have first is strictly increasing, then decreasing, and then again increasing. Okay, now let's see how we code it. Okay, what we have been given is a nums array. Okay, given as nums. Now first what we know what is our n. Okay, n we know, which is nums dot size. Okay, and what is our I? We started from 0. So first what we'll see whether first it is increasing or not. We'll run a while loop, okay, to check if nums of I is greater, smaller than, strictly smaller than nums of I plus 1. Then only it will be increasing. And we'll run a counter. After this loop finishes, if we have no element, it would have been gone till n. So we'll check if I is equal to n minus 1, then it would not be, or if I is equal to 0, then also it would not be possible. Okay, so we'll simply return false. That means it is not strictly increasing only, phase 1 is not only. Now again we'll take another variable I, because we got our I. Suppose here till we had the increasing, so now we'll define our p equal to I here. Okay, then we'll see the down phase while I plus 1 is less than n, and now we have to check decreasing, strictly decreasing. Okay, is greater than nums of I plus 1, and we'll increase the I. Now again we check if our I is equal to p, that means it is not increased, or if it has gone till end, that means we don't have any value left for our third phase, which is strictly increasing again. In that case we'll return false. Okay, now simply we'll check for our last phase, which is again increasing while I plus 1 is less than n, and again we have to check for increasing. I is less of I plus 1. Okay, and I plus plus. Simply we'll return now I equal to n minus 1. That means if it has gone till the last one and minus 1 as increasing, then it would be true. Otherwise we have some other character which has gone decreasing but we don't want it, then it will return as false. Okay, this would be our final answer. Okay, so that was a simple question. If you have any doubt or suggestion, just put it in the comment section and keep